Good afternoon. I'd like to welcome everyone to this presentation on OpenStack infrastructure containerization. My name is Tobin. I'm a cloud architect with Dell. I'm located in the Cloud Centre of Excellence in Dublin, Ireland, and I suppose my love for OpenStack is I suppose taking me to looking at containerization and new ways that we can sort of look at how the infrastructure of OpenStack is deployed and managed. So today we're sort of going to take I suppose, an interesting look at how we can sort of leverage an infrastructure that is containerized and the possibilities of that exist with that. I suppose most of this is conceptual, I suppose, and that some of it we've done lots of experiments within the lab, and I suppose it's a different way of looking at how we may sort of create a more dynamic world for that infrastructure. So traditionally, I suppose, if we want to say traditionally, I suppose within OpenStack, we've had this model where we deploy the services directly to bare metal. Okay, if you look at a typical model, we're looking at Keystone, and we're looking at Glance, and we're looking at Cinder, and we're looking at Neutron. And these services, they're primarily sort of, web API services, or can be viewed in this model, and they service themselves very well to being containerized. But they're very tied to the actual operating system. And the operating system is very tied to the bare metal itself. Okay? By tying these services to the operating system and tying them to the bare metal causes complexities. Okay? Complexities around deployment, complexities around upgrade, complexities around management. Okay? And it makes them very static. Okay? The services themselves have a tendency to be deployed onto the bare metal or onto the OS, and they pretty much live in that mode. Okay, they don't move from server to server. They don't respond to the ever-changing throughput of API requests. Okay, the workload of the actual overall OpenStack itself, they're not responsive. We're very happy to have a situation where we tell our users of OpenStack that they need to create applications where OpenStack can scale according to the workload. But within OpenStack, we're very happy to have a very static and fixed situation because the workloads or the services within OpenStack are quite complex, and having a dynamic situation for those sometimes adds more complexity. Our work, or the work that we've been sort of looking at, is how can we break that linkage between the services themselves, the operating system, and the bare metal. And most people are familiar with Docker, and containerization. It's not new. Docker is new, but containerization isn't. And when you apply these services inside containers, it opens up a whole new world. So we looked at using within some of the work we've done. We looked at having a minimal OS, okay, an OS where it's just enough to get a container running, okay. This is a lightweight OS, as opposed to a fat OS where you've got all services and you need to maintain that, and then effectively layering the containers on top as services. And you start to realize that when we start to have those services layered on top, you can do a lot of things that you couldn't do when they're bound to the operating system. A container manager or a cluster manager allows us to sort of manage those containers in a way and move them around the cluster. And once we start to do that, we start to have a lot of pluses, like the ability to isolate the service within the container and its libraries. So normally we have library hell, which is a situation where you've got one set of Python libraries and you might have changes, and you might want to bring another service online that has a different set of libraries, and you've got into managing that. And it's easy enough managed, but when you have a large amount of nodes, it becomes more difficult. The containerization allows you to keep that separation of the services. And once you've got that separation, you can perform a lot of tricks, as I would say. We also looked at sort of how you would separate the data from the service itself, okay? Which is a very important part, because today we heavily link the configuration. So if you've got a service such as Keystone or Glance, on the left-hand side of this diagram, we've just put in Keystone, but that could be any of the OpenStack services. We normally have a situation where the data and the configuration itself is heavily linked with that service, meaning that if the node goes down, that you have a situation where the data itself is gone down with it, and if it gets corrupt, it becomes a problem. Okay, there isn't that separation between the service and the configuration data and the actual operational data, be it in the database. Okay, so if you start to disconnect the data from the service themselves, and if you take a database, we have a situation where we can separate the data from the actual the software that runs the database. We're in a very unique situation, okay? Because the services are truly throwaway objects, okay? And we don't have that reliance on the data being very close to them. The data also would live within the cluster. Okay, so this would also mean that by disconnecting the data lives within the cluster, and the losing of any one node is unimportant. If you want more resilience, you have more nodes within the cluster. The data itself, through that separation, gives you all of that goodness. A cluster we view as sort of a cluster or an infrastructure cluster. And I want to suppose get one point that's important here. The Nova, or the compute side of it, is not part of this equation. We're primarily talking about the actual the services the control services which would run the Nova compute infrastructure. And within that cluster, we have a situation where, if you've got multiple nodes, your services can be spread across all these nodes. In the event of a failure, the services would move dynamically between all of these nodes. Okay, you don't need to make your upfront and say, okay, I need to have this node tied to this service. Okay, you can have a situation where you can treat a cluster, a containerized cluster, and you can lay on your services on top, and they move and get spread evenly amongst that cluster. And if you lose nodes, they would move automatically between the nodes, creating a very dynamic situation. Basically, as nodes would become faulty, in this slide, you can sort of see there's two nodes gone faulty, and this way everything gets compressed down and laid on top of the existing nodes that are still operational. To do this, we're looking at using, I suppose, the good that comes with CoreOS and etcd, which allows us to create a sort of a repository, okay, and for information that is cluster-wide repository. So as nodes need to re-register themselves within the cluster, they can move, re-register, and if as far as new APIs are then presented through the load balancer, what happens is because they've re-registered, they're always easy to find. Upgrades become somewhat easier. Okay, it's not a panacea. It's not there's not a miracle here that sort of makes upgrades for OpenStack, but this does solve some of the upgrade issues. Okay, because effectively you're viewing things as a cluster-wide number of services, which means you can spin up, version 1 of, if you've got version 1 of Glance and you're going to version 2 of Glance, you can basically spin up the newest version alongside the existing version if they're compatible. Okay, and in that situation, you can basically do changeover and fallback if you need to. So, like I say, some of this is sort of experimental at this stage, where we're using CoreOS, you know, on top of our Dell servers, you know, the R620s, R720s, and you know, this has been experimental in the lab. There's some good results from some early stage, and there's some very good benefits. That's really it. Thank you very much.